Hello everyone, my name is Jeff. Today, I will be presenting my final year project, which proposes a solution to small data through interactive machine learning. Let me begin by briefly talking about machine learning. In a nutshell, machine learning comprises of 4 steps. In order to effectively train a model, a large enough dataset is required for accurate classification. Next step would be to determine an algorithm based on the type of data and preprocess the data accordingly to fit the model. Final steps would be to train, evaluate, optimize, and deploy the model. In machine learning, the most crucial piece of information needed is the data. Without any dataset, there would be no form of machine learning at all. This leads us to one of the biggest issues faced in machine learning. What if we do not have access to a large dataset? Instead, we are given a small dataset and are expected to perform machine learning with it. This problem leads to my proposed solution of using visual analytics to facilitate real-time user input in order to steer the direction of the analysis. Let us begin by going through the framework of my proposed solution. We will begin by performing the usual model training. Afterwards, a visualization of the model's performance will be given for analysis. Depending on the analysis, we will be able to artificially tune and adjust the dataset by adding new training samples. The process is repeated until ideal accuracy is achieved. In this project, we will be using 2 algorithms as a baseline. The 2 algorithms are random forest and the convolutional neural network. Random forest is an ensemble learning method used for both classification and regression tasks. A convolutional neural network is a specialized type of neural network designed for processing image data. The dataset we will be dealing with is the hand-drawn digits dataset from MNIST. The image shown is a sample of 20 digits taken from the dataset. The dataset taken from MNIST will be labeled Dataset 1. Dataset 1 will be the large dataset which will be used as the baseline for this research. Next, downsampling will be performed to produce Dataset 2. Dataset 2 will be the subject of this research and user interaction will be performed on it. User interaction will be performed by using the image data generator class provided by Keras. This class will perform data augmentation based on several parameters such as rotation and shifts. Moving on to the results, we've managed to achieve an accuracy of 96% with dataset 1 on the random forest algorithm. With the smaller dataset 2, we achieve the expected lower accuracy of 89%. From the classification report of dataset 2, we can see that the labels with the lowest F1 score belong to labels 5 and 8. We then tune the training set by using image data generator and artificially add 80 training samples and 20 test samples to each of these labels. Although the accuracy remains the same at 89%, the F1 score of labels 5 and 8 increased, indicating a better classification result. Similar to the random forest algorithm, we move on to perform the same tests on the convolutional neural network. We've managed to achieve an accuracy of 99% with dataset 1. With the smaller dataset 2, we achieve the expected lower accuracy of 90%. From the classification report of dataset 2, we can see that the label with the lowest F1 score belongs to label 8. We then tune the training set by using image data generator and artificially add 80 training samples and 20 test samples to this label. The accuracy increased slightly to 91%, and the F1 score of label 8 increased, indicating a better classification result. In conclusion, we experimented with 2 different modeling techniques, the random forest and the convolutional neural network. Both models performed to expectations and managed to achieve better accuracy due to user interaction. I hope you find this report to be informative and valuable. Should you have any questions, feel free to email me. Thank you.